Welcome to our 22nd lecture on quantum mechanics for BSc students, and also NET students can study this. Quantum mechanics 22th lecture, probability current density or equation of continuity in probability or in quantum mechanics. So today we study an important topic that we call as probability current density. You distinguish it with probability density. Probability density is not probability current density. The relation is entirely different. Today's topic is probability current density, and that is coming in an equation called equation of continuity in quantum mechanics. Let us see what is it. So at first I will give the equation of continuity in probability. Equation of continuity in probability is del dot j plus dou p by dou t. You read as dou p by dou t is equal to 0. Del dot j plus dou p by dou t is equal to 0. Where j is the probability current density, p is the probability density. You understand the two terms. J is the probability current density and P is the probability density. P, it is psi star or modulus psi square. This equation is similar to the equation in electrodynamics. equation in electrodynamics. A similar equation we study in electrodynamics, that is del dot J plus dou rho by dou T is 0. And that equation is electrodynamics, where J stands for current density, I by A, rho is charge, volume charge density, Q by V, that we know. So similar to the relation in electrodynamics, there is a relation in quantum mechanics, and that is the equation of continuity in probability. It is del dot J plus dou P by dou T is 0, where J is the probability current density and P is the probability density. The two terms you distinguish. And it has a derivation, and that you have to carefully note the steps. We start with the time-dependent Schrodinger equation. Time-dependent Schrodinger equation, TDSA. That is I h cut dou psi by dou t is equal to minus h cut square by 2 del square plus v psi. That we mark as equation number 2. Equation 1 is the probability current density equation, the equation of continuity. This equation number 2 is the time-dependent Schrodinger equation. The complex conjugate of this equation is obtained by replacing psi by psi star and I by minus h. അപ്പോൾ ഇതിൻ്റെ ഈ ഇക്വേഷൻ തന്നെ കോംപ്ലക്സ് കോൺജുഗേറ്റ് നമ്മൾ എടുക്കണം. ഡെറിവേഷൻ ശരിക്ക് കെയർഫുള്ളായിട്ട് നോക്കണം. അപ്പോൾ ഇത് ഈ ഇക്വേഷൻ്റെ കോംപ്ലക്സ് കോൺജുഗേറ്റ് എടുക്കണം. എടുക്കുമ്പോൾ I മൈനസ് ഐ ആകും, psi സ്റ്റാർ ആകും, വേറെ മാറ്റമൊന്നുമില്ല. That is minus I h cut dou psi star by dou t is equal to minus h cut square by 2 of psi star del square plus v into psi star. Complex conjugate എടുക്കുമ്പോൾ psi star ആകും, I എന്നുള്ള മൈനസ് ഐ ആകും. Now you read the next part. Multiply equation 2 by psi star. That is equation 2, the top one. And equation 3 by psi. ഇപ്പോൾ രണ്ട് ഇക്വേഷൻ നമ്മൾ ചെറിയൊരു ഓപ്പറേഷൻ നടത്തുകയാണ്. ഒന്നാമത്തേനെ psi star കൊണ്ട് ഗുണിക്കുക, ഫ്രണ്ടിലാണ് ഗുണിക്കേണ്ടത്, ഫ്രണ്ടിൽ ഗുണിക്കണം. രണ്ടാമത്തതിനെ psi കൊണ്ടും ഗുണിക്കണം. ഇപ്പോൾ ഇക്വേഷൻ 2വിനെ നമ്മൾ psi star കൊണ്ട് ഗുണിച്ചിരിക്കുകയാണ്. ആദ്യം I h cut psi star, I h cut കോൺസ്റ്റന്റ് മുന്നിലെടുക്കാം. I h cut psi star dou psi by dou t is equal to psi star inside bracket minus h cut square by 2 del square plus v psi. Second equation, we multiply it by psi. Minus I h got psi dou psi star by dou t is equal to psi into it minus h got square by 2m del square plus v psi star. That is equation number 5. Now what we do is equation 4 minus 5. For you look, this is 4, last one. And here there is 5. Subtract 4 minus 5. So when we subtract 5, it is a minus equation that will become plus. So in the LHS we get IH got psi star dou psi by dou t plus minus or minus. IH got psi dou psi star by dou t. LHS is over. RHS. Psi star into minus h got to square by 2 del square plus v into psi minus. Here the RHS term of equation 5 is plus though. So here it will become minus psi into minus h got to square by 2 del square plus v psi star. A simple step. What we have done is 4 minus 5. 5 is subtracted from 4 as usual equations. Nothing complicated. So the two equations we subtracted, and in the LHS there are two terms. And from the terms in the LHS, we take IH cut outside. So we get IH cut into psi star dou psi by dou t plus psi into dou psi star by dou t. That is LHS. Is equal to, in the RHS we remove the brackets. Psi star into, you note the into, and minus h cut to square by 2m can be put in a bracket. Psi star into minus h cut to square by 2m del square psi. Psi is taken inside. Psi is taken inside. Plus psi star del psi multiplied. Plus minus into minus plus psi h cut to square by 2m del square psi star minus, there is a minus outside the bracket, minus psi v psi star. And look, in the RHS, the potential term psi star v psi and psi v psi star, they are opposite terms, they will cancel. So V is a scalar potential function. So if it come in the middle of psi star and psi, there is no change. Both are same. So these two will cancel. Even though the order is different, psi star v psi, psi v psi star, since V is coming in the middle, they can be cancelled. We will not change the state of psi. So the V term, two terms, plus minus in the RHS cancel. In the LHS, we have taken IH cut outside, and inside bracket we have psi star dou psi by dou t plus psi dou psi star by dou t. And for this we apply the product formula. You see the step in the bottom. IH cut is written as such. The two terms in the bracket we can combine using product formula in differentiation. That is dou by dou t of psi star psi. You know, dou by dou x of uv is equal to u into first function into derivative second plus second function into derivative first. So this step dou by dou t of psi star psi means the step given above, that is psi star dou psi by dou t plus psi dou psi star by dou t. I hope you understood. Dou by dou t of psi star psi, when we apply product formula, we get the above step. First function into derivative second plus second function into derivative first. So LHS is complete. And in the RHS, we have seen two terms cancelled. From the remaining terms, you take h cut minus h cut square by 2 outside. So inside we get psi star del square psi, and since minus is taken, there is a minus coming, psi del square psi star. Here these two terms will not cancel because in between the terms coming is del square. Del square will change the state of psi, so they will not cancel. If v is coming, they will cancel. Since del square or del is coming, the two terms will not cancel because even though they are plus and minus. You remember, previously when v is coming in between psi and psi star, we cancelled plus and minus. Here, del square is coming, so we cannot cancel them. Del square will change the state of psi. I think it is clear. And now we again see the step again see. Now we divide the equation by IH cut. We divide the equation by IH cut. So there is no IH cut in the LHS. It will come here. H cut and H cut will cancel. So one H cut will remain. I is in the denominator. So minus H cut by I into 2m. Inside the bracket no change. Psi star del square psi minus I del square psi star. Step repetition. Now by derivative of psi star psi is equal to, 1 by I is minus I. So minus I will be taken to numerator, minus into minus plus. I got by 2m. Del we can take outside. Del dot del. Del square is del dot del. So one del dot we can take outside. If you take like that, there is no mistake. Del dot of psi star del psi minus psi del psi star. Repetition. Top derivative of psi star psi is equal to, not repetition, we take a term in the RHS to the left. That is dou by derivative of psi star psi minus IH cut by 2m del of psi star del psi minus psi del psi star equal to 0. That is one minus sign. From the second term, one minus sign is also taken out. That is a dou by derivative of psi star psi plus IH cut by 2m del. Then the term inside becomes minus. Since we have taken one minus sign, minus psi star del psi plus psi del psi star equal to 0. That is d by dou by derivative of psi star psi plus IH cut by 2m del. Inside the bracket, the minus term is written last. Psi del psi star minus psi star del psi equal to 0. Equation number 6. Again, dou by derivative of psi star psi plus del. The constant we can write anywhere. IH by 2m is a constant we can take inside del. There is no change. Or when we differentiate, the constant can be taken out. Here instead we take the constant inside after del. So del dot IH cut by 2 bracket psi del psi star minus psi star del psi equal to 0. Let us call, this is a very important step. Let us call the term coming along with the del, that is IH equal to by 2m psi del psi star minus psi star del psi is equal to j. That is important step. ആ രണ്ടാമത്തെ ടേമിലുള്ള ഡെല്ലിന് ശേഷമുള്ള ആ ടേം ഉണ്ടല്ലോ IH equal to by 2m psi del psi star minus psi star del psi, അതിന് ജെ എന്ന് തൽക്കാലം വിളിക്കുക. അപ്പൊ അങ്ങനെ വിളിച്ചാൽ ജെയെ വിളിക്കുന്ന പേരാണ് പ്രോബബിലിറ്റി കറന്റ് ഡെൻസിറ്റി. സോ ഒബ്റ്റൈൻ ആൻ എക്സ്പ്രഷൻ ഫോർ പ്രോബബിലിറ്റി കറന്റ് ഡെൻസിറ്റി എന്ന് ചോദിച്ചാൽ നിങ്ങൾ ഈ ജെയുടെ ഇക്വേഷനാണ് പറയേണ്ടത്. ജെ ഇസ് ഈക്വൽ ടു IH equal to by 2m psi del psi star minus psi star del psi. And also you know psi star psi is the term in the LHS, first term in the LHS. Psi star psi is P, probability density. So these two values be put in the above equation. So we get dou P by dou T plus del dot J is equal to 0. We write in order. Del dot J plus dou P by dou T is 0. Equation number 7. This is the equation of continuity for probability. This equation is also known as quantum mechanical probability conservation equation. It is also known as quantum mechanical probability conservation equation. In this equation, J is called probability current density and P is called probability density. The probability current density J is equal to, you look at the equation, J is equal to IH equal to by 2m psi del psi star minus psi star del psi. Remember, J is equal to IH equal to by 2m psi del psi star minus psi star del psi. It is very important, and this was one or two times a straight type question. So that is solved with our 22nd lecture on quantum mechanics. The question may be derive equation of continuity in probability or obtain an expression for probability current density. That is all with our 22nd lecture. Tomorrow we come with next class we come with the expectation value. That is all. Thank you very much.